Welcome back. Well, in this chapter, Chapter 2, we're going to learn how to describe the data that we just collected. Chapter 2 deals with measuring and displaying techniques of data. We're going to learn how to graphically display the data and how to numerically display the data. We're also going to learn about measures of location, such as percentiles and quartiles, measures of the center, such as the mean, the median, the mode, and measures of spread of the data. Well, since this last example is so fresh on your mind, we're going to continue with this example of the number of books that we have. So up here I have the same example that we were just dealing with, where we have the number of books, the frequency, the relative frequency, and the cumulative relative frequency. This is the same example from the last class that we just had. Now in here, one of the parts that we want to know about is how to describe the measures of location. And the first measure of location that we're going to talk about is the percentiles. You may have received some sort of a test score in the mail at some point which said that you were in the 90th percentile or the 70th percentile of some form of a test. Well, what that means is that 70% of the people who took that test were at your score or below. If you were in the 90th percentile, 90% are at your score or below. If you were in the 30th percentile of salaries, that means that 30% of the salaries are your salary or below. So now let's look at this graph, or this chart actually. And this is why we have the charts going in order from the smallest to the largest, and we have our cumulative relative frequency. These help us to mark our location. Well, really, if I were to record all the data now, what I would record is 1, 1, 1, that's 4 of them, 5, 6, 7, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, here are 11 ones. Then I would go on to the twos, and I would record 10 twos. Then I would go on and record 16 threes. Well, I'm not going to do this much more, but I would continue doing that. And that's how I would record my data from smallest to largest. There were 11 ones and then 10 twos. And I'm getting these numbers from the surveying table. See, this table is a lot easier than just reading a list of numbers. All right, now let's say we wanted to find the 10th percentile. That means we're going to take our data from smallest to largest value. Oops, I just realized this was a mistake right here. I'm looking up and I'm seeing it should have then been 3, 3, 3, and I should have had the threes 16 times, not recording 16. All right, so hopefully you caught that on there. Just testing you all. All right, so now let's say we wanted to find the 10th percentile. That means that I'm looking for where 10% of my data are some value or less. Well, in this example, we had 50 data values. If we added up the frequency, we came to 50. 10% of 50 is 5. So we're looking for where we can find 5 of our data values. So we'll count 1, 2, 3, 4, 5. So right after this 5th number is where we'll draw sort of a wall. And in between this number and the next number is where our 10th percentile will be. Well, if we look in between a 1 and a 1, we get 1. And so we can see that the 10th percentile is 1. That tells us that 10% of our data were 1 or less. Now let's look at the 30th percentile. The 30th percentile of our data, if we come across here, well, 30% of 50 is 15. And so we're going to count up 15 values. Well, if I get to the end of the ones, I've counted up 11 values. 12, 13, 14, 15. So the 15th percentile will be right after this one, this number 2. It's in between this 2 and the next 2, or it's the number 2. 15th percentile, I'm sorry, the 30th percentile will be the number 2. We count up 15 values. Well, if we have more to do, we could do it, but it gets a bit tedious. And that's why we use this chart. For example, what if we had 74,000 values? We did a survey. Pharmaceutical companies often survey hundreds of thousands when they're trying to test new drugs to put on the market. We don't really want to do that and sit there counting each time, 1, 2, 3. And so we use this summary chart. Now, this is how we take advantage of the fact that we have the cumulative relative frequency. What this tells us is that the first 22% of our data are 1. So we have 22%. By the time we get to the end of the ones, we've used up 22% of the answers. By the time we get to the end of the twos, we've used up 42% of the answers. And so if we wanted the 30th percentile, we look here and we say, well, by the time we get to the end of the ones, we've only used up 22% of the responses. In order to use up 30%, we have to start into the twos. But when we finish the twos, we've used up 42% of the responses. So the 30th percentile needs to be somewhere after the ones end and before the twos end, meaning it's going to be a 2. Let me try another one. How about the 90th percentile? Well, going down to this chart here, you can see that when we get to the end of the 4s, we've used up 24, end of the 4s, we've used up 86% of our data. And by the end of the 5s, we've used up 96%. So our 90th percentile must be a 5. It's after the 4s end, but before the 5s end. So our 90th percentile would be a 5. The percentiles are one type of measure of location. Another type of measurement is what's called the quartiles. And the quartiles are a different measurement that we have, and they're just special percentiles. And if you think of this in terms of money, you can think of money in that if you have 1 quarter, you have 25 cents. Well, the first quartile is the 25th percentile of all of your data. The second quartile has a special name besides being the 50th percentile, and that's that it's the median. It's where half of your data, 50% of your data, is that number or below, and half of your data is that number or above. The third quartile is the 75th percentile, and that's where 75% of our values are that number or below. And the fourth quartile is actually really not labeled quartile 4. It's usually called the maximum value, where we have our highest value. All right, let me pull down this chart again and see if we can come up with the first quartile. So we're going to be looking at the cumulative relative frequency table here. And we see that by the time we finish the ones, we've used up 22% of our data, values or responses, and not 25% yet. But by the time we finish our twos, we've used up 42%. So that tells me that the first quartile is the number 2. It's after the ones finish, but before the twos finish. The second quartile is the 50th percentile. Well, by the time we get to the end of the twos, we've used up 42% of our data. By the time we get to the end of the threes, we've used up 74% of our data. So the 50th percentile would be after the twos end, but before the threes end. So the 50th percentile would be a 3. The 75th percentile, okay, we look to the threes end at 74%. So it's after the threes end, but before the fours end. So our 75th percentile, or our third quartile, would be the number 4. And our maximum value is the number 6. So here's how we would fill in this chart down below that we have right here. We would have the quartiles, the 25th, the quartile 1, quartile 2, quartile 3, and the maximum value. Now, One of the reasons that we want to use the quartiles is that they give us a good summary of the spread of the data. It's not very detailed, but it is a little bit of a summary that we find very useful. And we can use this summary to do a quick graph. One of the types of graphs that we study in this class is called the box plot. And the box plot is a quick type of a graph which helps us to display our data. Every day, if you were to read the newspaper, there would be at least one type of a graph in the newspaper. We have histograms, which we'll be able to construct in just a minute, box plot, pie charts, bar graphs, lots of different types of graphs. And the two that we're going to do in this chapter are the histogram and the box plot. The main use for the box plot is in comparing several groups. So you usually will not see a box plot alone. Usually you'll see a box plot in comparison with several groups. Well, we're going to construct one now for the data that we just had based on this study. Okay, based on this study that we just did of the books, because I know that that was an exciting study and you probably don't want to let that go yet, we have the minimum value was a 1, our first quartile was 2, our median was 3, third quartile was 4, and our maximum was 6. Now, how we construct the box plot is we draw a box around going from the lowest, the first quartile to the third quartile. So this is a rectangle, and it's going from quartile 1 to quartile 3. In the middle, we're going to put a dotted line or a dashed line at the median. The median here is a 3, so we have the dashed line coming down at 3. And then we have whiskers. So the other name for this often is box and whiskers plot, and both names are interchangeable. They both mean the same thing, and they were both discovered or invented, I guess, invented by John Tukey, who's a statistician who worked with a lot of displaying of data. Okay, so this first whisker goes from the first quartile down to the minimum value. And this one goes from the third quartile up to the maximum value. So how you typically construct these is you have a number line scaled going from your lowest to your highest value. Then you construct the box from quartile 1 to quartile 3. And we put the median in, the dashed lines. And then we add the whiskers at the end. Now, often students say, well, what if the median is the same as one of the quartiles? In that case, and on several of the homework problems that actually is the case, your dashed line will be superimposed on the quartile that it is. All right, now I'm going to show you an example of how a box plot has been used on this campus in comparison. I had a student who went and took what was called one of these interest studies. She was trying to decide what to major in, and she had no idea. And I know you probably can't read this, but I will move this over a little bit. Now that you know there's writing here, I will go in here and zoom it in and let you see the graph. And what the graph did was it compared females and males who were interested in a certain profession, and it put a dot by this student to show where her interest was compared to other males and females. So this one right here was on agriculture. You can see the first quartile, the median was actually, in this case, instead of being dashed, it's superimposed as or reverse imposed. And then the third quartile, and here are the whiskers, and the men. So the men have a higher interest in agriculture than women, and this student had a lower interest compared to most women. Now let's look at the military. Here is the military. Here's the man's box plot. You can see that the women and the men start about the same. They have very short first quartiles and first quarters, and then the median is down here for women and up here for men. Men have a much higher interest in the military for women, and this student had a much lower interest than even most women. Now just the opposite, the next one was for athletics, and see where this student falls for the athletics. So this box plot would be used to compare her to females and compare her to males also. Okay, another type of box plot you might see would be in the homework that we have. There are several problems in the homework where you have box plots that sort of look funny, where the first quartile and the median might be the same, or the second quartile and the third quartile might be the same, or maybe there's no whisker. Well, if there's no whisker, that's just telling us that that endpoint is the same as one of the quartiles. You'll need to go through and look through these and study them carefully to determine what the box plot is trying to say to you. Aside from the box plot, the next type of graph that we're going to do is what's called a histogram. And a histogram is a graph that takes our data, and depending upon how it is that we are counting or measuring our data, it displays it. Sometimes the histogram will display this in an abbreviated way. For example, in this case, we don't know what our values are, but all the values that fall in between this value and this value are displayed right here. All the values that fall this one and this one are displayed right in this one. And all the data values that fall here to here would be displayed in this graph. This histogram we would consider to be bell-shaped. It's starting to come up and then it's coming down. Here we have, oh, we haven't learned this word yet, but we have a bimodal distribution. We're going to learn this in a minute. Bimodal means we have two peaks, one over here and one over here. Here we have a distribution which is sort of truncated. It has a long left tail and then it stops. Down below it, we have a graph that is skewed to the right, meaning there's a long right tail. We come up, then we come down, and then there's a long right tail. Now, an example of this one might be incomes. So we might have U.S. incomes where they start to go up and they reach some peak. Maybe for, this is somewhere from 60 to 90,000 possibly. And then they start to come down, but then there's a long tail of people who are earning, just a few people who are earning a lot more money. This example here would be left skewed. We have a long left tail. And here we have an example of a histogram that's actually relatively uniform. It's flat across the top, meaning that we had about the same. Now, we wouldn't expect exactly the same, but in this case, we have sort of the perfect scenario with no randomness in our data. All right, now, once we have our data, we need to display it in our in a histogram. So I'm going to put back right here this data. This was the number of books that we had right over here. In your workbook, you have instructions for how to enter this into your calculator. And so you could enter this into your calculator following the instructions. And I'm going to do that right now on here so that you will see me doing it. If it goes too quickly, just go back to the calculator instructions that are in your textbook. So here I have the graphing calculator. I happen to be using the TI-83, and I'm going to enter the data by editing. First, I'll clear off all my lists. I'm going to clear my list 1, my list 2, my list 3, and I'm clearing them out. So those are now emptied out. All right, now what I'm going to do is I'm going to go back into the stat, and the stat button is right here. It says stat. That's the hint that it's statistics. And I'm going to edit the data. And in L1, I'm going to put the data values, which were the book. These were the data values. In L2, I'll put the frequencies. Let's see what we had, 11, 10, 16. Then the next one was 6, 5, 2. So if this is going too fast, then what you need to do is come to see one of the instructors or get the videotape or practice with the instructions that are in the workbook. Now my data is entered. So I'm going to exit from here and go back into, this time I'm going to go into the stat plot, which is right up here. So I press second, stat plot, and I want to graph this in plot 1. And so I'll highlight the 1. I want to turn this plot on, so I'll hit enter. And now I'm going to go over, highlight the histogram. And the next thing is asking me where my data is. Well, my data is in L1 and the frequency is L2. So this is all set. Last thing we need to do is adjust the window. And our data is going from 1 to 6. We want to surround 1 in the histogram, so we go half a unit below. In fact, I'm going to go to negative 0.5. That's actually 1.5 units below. And then I'll go up to about 6.5. The x scale of 1, well, in this case, my bar has a width of 1 because I'm counting by ones. I'm saying how many books, so I want to count by 1, so I'll have a width of 1. Typically, we put 0 for our y minimum if we're doing a histogram because we're going to build up. And the y maximum, my highest frequency was 16. And I'm going to graph a little bit higher just so that I can get past this. And now I'm just going to press the graph button. And you'll see here is the histogram. So here's the histogram right here. If we want to find out what this looks like, we can press the trace. And what I'm told is that the very first bar goes from negative 0.5 to 0.5, and there are no values in it. Now I'll just arrow over. You can see this highlighted here. I'll just do this one because it's right over here. It tells us that this bar is going from 2.5 to 3.5, and it has a height of 16, which we knew that because that was the frequency for that. If we wanted to do the same thing, now our data is in with the box plot, we can go back to the stat plot. Over here, go second stat plot, and everything is all set. But instead of doing a histogram, I want to do a box plot. So I'll press enter and go down until I'm at the middle box plot right here. Press enter again. Now when I press the graph, I'm going to get a box plot. And if I trace it, it tells me that I have a median of 3. My left value, median, remember, is the second quartile, is 2. We can arrow over and so forth. All right, well, now we know how to enter the graphs onto our calculator and enter our data. And we need to next talk about the measurements of the central tendency. The first measurement that we have of the central tendency is what's called the mean. The mean is the same as the average, and this is the one that you most often have used. We have a sample mean, which we write as x bar, and we have a population mean, which we write as the Greek letter mu. So the mean and the average are interchangeable words. The formula, I left it blank here. It's in your textbook, and you can get it through here. But just know that when we're doing a survey, we have the sample mean. When we have a population, everybody, it's the population mean. The median is the same as the 50th percentile. That means the value such that half the values are that number and below, and half are that number and above. And the mode is the most common value. Once we know the measures of central tendency, we're going to measure, the next thing would be the spread. And the easiest measurement of spread is what's called the interquartile range, the IQR. And this is from the third quartile to the first quartile. Now in our book example, the third quartile was a 4, and the first quartile was a 2. So our interquartile range we would have as 2, meaning that we have a spread of 2 for the middle 50% of our data, going from the 25th to the 75th percentile. The last measurement of spread that we have is what's called the standard deviation. And the standard deviation is actually the most common measurement of spread. In this case, what we're doing is we're taking every value and finding how far it spreads from the mean, and we're finding the average of those. Since we would have some positive and some negative ones, we square it and then take the square root. Now, I never want you to do this by hand. We're going to do this once on the calculator right before this section now ends, and I don't want you to ever work on this by hand because the formula is sort of a pain to do. I'll do it once for you up here, and then you'll be able to practice this on your own. All right, so in this case, we have our data entered first, and we're going to go back into Stat and now calculate. And we're going to calculate our one variable statistics. Press Enter. And we want this on L1. Well, where L1 is behind the 1 key, if you can see this, second L1. And then the comma is right here above the 7, on this calculator anyways. And then second L2. And once I do this, what I get is all the information that we could work out by hand with the formulas in the textbook. We find that the sample average is 2.8, meaning the average number of books in a backpack was 2.8. We skip the next. The standard deviation was 1.3997 or 1.4. 50 people participated in the survey. So what we're looking at for a survey is X bar, S, N, and now there's an arrow, which means that there's some more stuff below. So I'm going to arrow down, find the minimum value was 1, we knew that. First quartile was 2, third quartile was 3, and the maximum was 4. All right, to summarize what we just did now, what we did for this past 30 minutes, sort of on a whirlwind, is we took data that we had collected and we started to look at ways to display the data. We have graphs to display the data, the box plot and the histograms, and we had summary statistics such as the sample mean and the standard deviation. You're now going to go and try working on these on your own and try interpreting. The main part to the graphs is to be able to interpret it. And when we come back, I'll be starting the next chapter, chapter 3. Bye-bye.